Okay, welcome back to the second part of the simulation. So as you can see on the screen here, um, our calculation is completed after it run for, okay, so it run for 600 iteration. So as you can see here, we have a 6 cycle of pressure because just now, as what you said just now in the system. So when you set in the system just now to run at a time step of 2.85 10 power 5 for 600 time step, meaning you ask the program to run 600 time steps. With here you will see 6 cycles. So how to calculate, how to count one cycle. So from here to here is one loop or one cycle. This is 1, 2, 3, 4, 5, 6. So you have 6 cycle over here. Okay, the next steps you're going to, after you run, remember to save your file. So go to export case and data here. We're going to save as yes. Okay. We're going to update our file, and we're going to saving and post-processing our time-dependent data set now. So at this point, the solution has reached a time period state, and what you see on the screen here. So we try to study how the flow change within a single pressure cycle. We'll try to see what happened to a single cycle. You will now continue with the solution for 100 more time step. You will use the ANSYS runs solution animation feature to save contour plots of pressure and Mach number at each time step, and auto save features to save the case and data file every 10 time steps. So we will do some automation steps. So after calculation is complete, you will use the solution animation as a playback to see the animate pressure and Mach number plots over time. So how to do that? So we will request the saving of case and data every 10 times. So we're going to go to solving here, solving, and then we control the activity, go to autosave here. So to bring up the autosave window, and then enter save time file every 10 steps. So every time 10 calculation, you will save as one file. So so each time for save associate case file, this one. So click each time, and then the rest we retain time steps. Then click OK. After that, we will create an animation definition for nozzle pressure contour plot. So go to solving, activity, create solution animation. This one. So we will run an animation. So the first one we'll look at pressure. Name of the animation is pressure. So record every one not iteration. We are looking at time step now. Time step. We're going to save. You can save in HF file or PPM image. So at the moment we will save in memory. Yeah, we save in memory. Then window ID number 3. So ID number 1, number 2, and then there will be one window called third window, and we assign as ID number 3. Okay, then we will okay, after that we will create a new object under contour. So go to new object here, create contours. So contour names here, we will look at pressure. And static pressure field, we need to see the node value, uncheck the auto range. So we need to input the range for 0.25 ATM to 1.25 ATM maximum. Then we will select okay, then we'll click save or display and close. So we will close this one. So here, animation definition here, you select this one, Control 1, and then click Control 1. Click OK. Then we create animation definition for Mach number plot also. So we will create another window for Mach number. We already have the static pressure. Now we want to create for Mach number. Repeat the same process. Go to solving, activities, create, solution animation. Now we want to see at Mach number. Again, we will look at 1 every time steps. We will save in memory at this time. So you can choose a PPM image or an ANSYS file. So PPM image means you will capture image and you will see lots of image file in the working folder. And ANSYS file is like a video file. You will save in the folder. So later you can access this one. So at this moment we'll save in memory. So number 4. So go to new object again, go to contours, and contour number 2, we're going to look at velocity, and velocity here, we're going to look at Mach number, yeah. So Mach number, again, disable auto range. We're going to put in 0 Mach number to maximum 1.3. 0. Okay. When you click display, you will see a new window come up. Okay. Mach number window come out. Close. And then we're going to select contour 2. Then click OK. So we have 2. So we'll continue the calculation by requesting 100 time steps. So by requesting 100 time step, you will match the solution through an additional of 0.0028 second, or roughly 1 pressure cycle, because one pressure cycle is 100 steps and individual is 2.8 10 power 5 second. So with autosave animation features active, which already done previously, the case and data files will be saved approximate every 0.00028 second of the solution time. So animation files will be saved every 0.00028 second for the solution time. So we go for solving, run, calculation, advance. So we're going to look at here. So we're going to run for 100, yeah, 100. So when calculation finish, you will have 10 pairs of, after finish, you will have 10 pairs of data file that will be 100 pairs of contour plots stored in the memory. So for the next few steps, you will play back the animation sequence and examine the results at several time steps after reading in pairs of newly saved case and data file. Okay. calculate. Okay, so you could calculate 100 more steps. So you look at residue. So look at here, you will run at another 100 steps here. After the computer completed the calculation, we will play the animation of the pressure contour. We almost at the end of the tutorial. We wait for the computer to finish the calculation, and then we'll show you the animation, and that's it for this tutorial. So again, if you're watching this video, you can fast forward until you see the calculation completed. Maybe another 1 to 2 minutes. Okay, the calculation is completed. So we're going to play the animation. Click OK. So how you play the animation, you go to results. Go to results, animation here. So you go to solution playback, edit. So you're going to see the animation. So we're going to look at pressure first. And then we're going to open up pressure, this one. And play. So you're going to see the pressure contour is changing from between the number of 0.25 until 1.25 at the end. Yeah. So this, how fast is this? So again, you can change all these things. So again, this is the contour for pressure. Okay. So we'll repeat the same for mark number. So go to animation again, animation playback, edit, and then go to mark number, click the mark number window and click the play. So this is how the mark number change. As you can see, it changed from some area will experience 1.3, some area will have a stagnant pressure like this area. So again, all this photo was saved inside your working folder. You can go and access each of them. Yeah. Okay. So the further explanation, you can look at the screen here. All right. So go to the slide and read on how to save the file in MPEG file, TFF file. Yeah. And in our case, because we set in a memory, so it will now is current in the memory. So once you close the program, it will not be there. You will lost the data. Yeah. So the animation frame format can only read back into the playback dialog display in the front session. So you can read the file from there. So let's say we look at a time frame at 660 time steps. We're going to open up our case data files with its name, the file name 660 cast into the Fluent. So how we do it? So you go and read. So you go to file, you go to import case and data file. Yes, so you're going to read, go to your working file and find time step for 660. So time step for 660, if you take 660 times the 28 10 power negative 5, you will get about the time will be 0.018849 seconds. Click this one, click OK. Okay, the program is reading the exact time frame at 0.018849, right? So you're going to plot vector. We're going to see vector at that particular time frame. So we're going to look at a vector at a time of 0.018849 second, right? So if you take 660 times the time frame that you set for each time step here, you take 660 times 2.85 10 power negative 5, you will get the time at that particular time frame. So we go to post-processing, go to graphic, go to vectors again, go to edit, going to see vector. So we're going to see velocity, and then we're going to scale 50. I'm going to skip for 50. Scale 50, skip every 50 steps. So we're going to see a arrow or time frame or every 50 calculation. Then we click display. So you'll see the arrow of the vector every 50 steps. Yeah. So you will see that our maximum velocity is 259 meter per second at the time frame of 0.018849 second. Yeah. So you should able to open up exact file. It's being told there. So maximum is 259 at this region, and minimum is 1.2 meter per second, which is at near the wall over here. And if you zoom in, you will see some backflow. The velocity backflow happen here and here also. Yeah. So yeah, this is how you read your file. Okay, so go for the conclusion. So this is the time frame 0.018849 when you open up the data and case file 660. So the summary. So we in this tutorial, what we learned is that we generate a steady state solution in the transient case, and then also we set the solution parameter for implicit time stepping and apply user-defined transient pressure profile where we import the C file, the text file, and then we do mesh adaptation. And then we have some automate the safe solution steps, and we also show how to create the animation. Okay, so for future improvement, for better accuracy, you can increase the order of solution in the setting. So in this case, we choose second. You can go a bit higher if you want. Again, it will take more times to process. Yeah. Okay. So with this, we end our recording.